Hello guys, welcome back to our introduction to program with Python series. So in this video, we're going to be looking at exception handling in Python. Whenever you're writing a program as a beginner or even experienced programmers, right? You sometimes you run into errors, right? You are expecting something to happen, but you're not sure if it's going to happen. Like some exceptions can occur in your program that you need to be able to take care of. If you don't take care of them, your program is gonna crash, right? The last you want to do is to have your programs crash, right? You need to handle these exceptions and just like output an error in case maybe you expect task A to happen and task A doesn't happen. Then you need to be able to handle that and then be able to like prompt the user that hey, this exception occurred or this error happened, instead of actually letting your program to crash, right? You can have some exceptions like that. First, let's say that you have to open a file and unfortunately the file was deleted, right? So you failed to open the file. So instead of letting your program crash because you couldn't open the file, you could actually just prompt the user that, hey, we actually failed to open the file. You handle that exception of the file not being there, right? Or the exception of failing to open the file. So that's a very important concept in programming, and that's what we'll be covering in this video. So let's go ahead and jump into it. So I'm in here inside of my VS Code. I'm going to go ahead and create a new folder. I'm going to simply call it exceptions or exceptions. And then in exceptions, what I'm going to do, I'm going to create a file, and I'm going to call it part, I think part 30. I haven't I lost track of the files. Let's just call it part 30 or whatever. Let's just call it part 30. And so let me just explain to you, let me just write the exception, just keep the what you're doing up here. So exception handling. Okay, so the process of dealing with exceptions is just called exception handling. Okay, so how does the exception handling work? Exception, to do with exception, we have something called try, catch, and try, except, and finally. So if you're coming from other programming languages, I just said catch. Yeah, in other programming language you have try, catch, and then finally. In Python we have try, except, and finally. So to handle exception, there are two ways of doing it. So we say try block. We have the try block. So let me just write for you try block. So try block is just basically try. What's basically write what you want to execute in here in which an exception occurs. So probability, let me just say code probable, I don't know, probable, probable, I don't know, probable to exception, right? So in here, and then you have the except, where you handle the exception. So you handle the exception here in this block, handle the exception, and then finally we have the final keyword. So finally, and then you run no matter what happens. So we just say run anyway. So run anyway. So I'm just going to use pass here just to avoid the errors. I'm going to say pass, and also up here I'm going to use the pass keyword. So pass, just like that. So good. So that's how that's the syntax of creating exception and handling exceptions in Python. So we have the try block that for example, you're trying to read a file, right? The file might not exist. That's an exception. So that code goes in here, right? In case the exception occurs, maybe you want to prompt the user. So you prompt the user within the exception block. And then final block, the final block will run no matter if an exception occurs or an exception doesn't occur. It will always run. But most of the time in exception handling, you'll be dealing with a try and catch block. Finally is rarely used, okay, from my experience. So let me just go ahead and try to create, let's write a simple code and try to deal with an error. So in mathematics, you can divide a number by zero, right? A number divided by zero is undefined. So in programming, if you try to divide a number by zero, you get an exception. Your program crashes. So let me just say print, and I'm going to go ahead and print 2 divided by 0. That's not possible, so our program is going to crash. So let me just change directory into my exceptions folder, and then just say python python 3, and then path, and then run that. So you can see you get this error of division by 0. You can divide now by 0 in mathematics, right? You get the undefined, but in programming you get an error which is called the division by 0 error, or division the 0 division error. Okay, so how do you make sure that your program doesn't crash in such an event? And that's where you can have a try and except block. So I can just go here and say try, and I can simply say, I can still say result, and result is going to be equals to 2 divided by 0, right? And I'm going to go ahead and try to print it out. So print, I'm going to go ahead and print out result here. Okay, so I'm going to go ahead and have an exception. In case any exception occurs in the try block, you're going to go ahead and handle this exception, and you're just going to go ahead and simply say print, I say exception occurred, and just like that, or cut, just like that. So now if I go ahead and try to run the program again, which was giving us an error, now instead of our program crashing and throwing out a bunch of errors, it's just going to go ahead and simply tell us that exception occurred, because at this point this is not possible. So our program is going to throw an exception. at which point the program is going to jump from this try block and it's going to go into the except block, and it's going to execute whatever code we put inside of the except block, right? So we're going to simply going to go ahead and print exception occurred. So if I go back and run the file again, now you can see just exception occurred. Instead of throwing out all this bunch of errors, we simply just get exception occurred, and that's simple, right? So good, that's how you can handle exceptions in Python. But in case an exception doesn't occur, so for example, we can divide 2 by 1, right? And that should be 2. That's not going to throw an exception. So we're not going to go into the exception block. We're not going to go into the exception block. We are only going to go into the exception block in case an exception or an error occurs within the try block. So if I run the code again, now we just print 2.0, and there was no exception, so we didn't go to the exception block. So that's how you can handle the exceptions in Python. Right. So we can also have specific, we can have multiple exceptions, and you can also go ahead and have specify the exception that you want to handle. Okay, so each of these exceptions has its own name. So the exception of trying to divide by 0 is called the division, zero division error. So now that's the name of the exception, and you can use this exception right here. So you can say except, and you can. So good, now you see how to deal with exceptions in Python. Now, if exception occurs in Python, we can give it an explicit name. So we can accept the exception and actually print out the exception itself. So you can say accept exception as E, and then we can go and actually print out that thing. So you can just print out the exception which is stored in the variable E. So we just accept the exception as E, and we're simply printing out E. So if I go back in my code, run again, you can see no exception occurred. So now let's go ahead and actually change this to be back to 0, and let's run the code again. Now we just print out the exception, which is the division by 0 exception. So instead of throwing out all this bunch of errors, we just simply got division by 0 exception, which is what we got right here. So you can also accept exceptions like that. Now you can also give your exceptions the name. So you can see that the exception. Let me just go back into my terminal. See the exception which occurred here is a 0 division exception. So you can simply copy that and go in here, and instead of just writing exception is just a keyword in Python that deals with it's a class that deals with general exceptions, right? So you can pass in a specific exception that you want. So you can pass in the 0 division error exception, and you're going to accept it as E. If you don't want to accept it in the variable, that's also fine. You can just leave the code like this format. Let me just delete E. I can just leave the code like this format, and it to also work. So if I print, just the exception occurred, but you can accept the exception as E, or store it as any variable that you want. This is a variable name. You can store any variable, but in Python programmers commonly call it E, right, for exception. So accept the 0 division exception as E, and then we print that exception out in case it occurs. If it doesn't occur, like just remove the exception. If it doesn't occur, then no exception will be printed out. So that's how you can deal with exceptions in Python. So good. We can handle more than just a single exception. So you can actually just say except. We can pass in multiple exceptions. Just say some print, let's say some exception occurred. So occurred here. So occurred. Okay. So in here, if you have multiple exceptions, again, you can have as many exceptions as you want, and each exception can have its own different name. So you are great. Let's say that you're having a math function that you can maybe expect 3 or 4 non-exceptions to occur. You can just chain them along here. So you can just have there you have the 0 one, you can have another one, another one, another one. But mostly in most common cases, the last exception is just the general exception, which is just the exception as E, or just say except and then simply do something with it. So in case all the above exceptions didn't occur, but another exception occurred that you weren't expecting, you are still able to catch that exception, right? So that's why the generic exception should always be the last one. So it could be in this format, or it can be in the format of exception as E, or something like that. Okay, yeah, so that's basically it. So you can chain multiple exceptions, and if you run the code again, we can see it works fine. So let's make sure an exception occurs, and let's see what we get. So it gets division by 0 exception. So it will only the exception block that occurred will be printed. So in this case, it's a 0 division error exception. So only the 0 division error exception block will be executed, and the generic one won't be executed. Or if you have any specific other one, it won't be executed because it was not the exception which occurred. The only thing that to be executed is the exception that actually occurred. In this case, it's a 0 division error exception, right? So that's one thing to keep in mind. Okay, good. So that's how we can see. Okay, you might be wondering, okay, where did I get this 0 division error exception? Once you work with Python, or once you work with the Python library, you will come across these exceptions in the documentation and online resources, and you just come across them and know them, because there are a lot of these exceptions. You can know them at the top of your head. So you can also create your own custom exceptions if you want. So you can do that by simply creating your own class, just a class exception. Just have the generic exception. So let's call it, sorry, let me just call it my exception. I'm just gonna call it my exception, and it's going to inherit from the exception class. Okay, if you don't see this kind of syntax before, don't worry about it. It's just object-oriented programming syntax. We'll look at object-oriented programming in the upcoming videos. Okay, so we can also pass in here our own exception. So exception exception is going to be called my exception as e, and then we can simply print out a e or something like that. Yeah, that's basically it. So you can have our own exception if you want, but in creating your own exception, you have to define a lot of stuff in here, but I'm not going to go into creating both creating your own custom exceptions in Python. But this is just a stepping stone of creating your own custom exception in Python. If you want to do that in the future, maybe I can make a video about it, but for now this is just an introduction to it, so I don't want to go into the details of it. So that's how you can create your own custom exception if you want to. Yeah, so that's basically it, how you can have exceptions. So one thing I didn't go over is the final keyword. So you can have finally, so actually it's called finally. So the finally keyword, what it simply does is that the finally keyword or the finally key block will get executed no matter if an exception occurs or an exception doesn't occur. So let's just say always always printed. So this block right here will get executed whether or not an exception occurs. So if this part of the code runs successfully without an exception, still the final block will be executed. If it runs with an exception, still the final block will be executed, right? So let's make sure that this doesn't run with that, doesn't have any exception. So if I go back, clear the terminal and run it again, you can see always printed, so which is in the final block, it gets executed. Now let's make sure an exception occurs. Again, let's run the code again. Now you can see get a division error exception. You also get exception occurred, and always print also got printed. Right. So good. So that's it. That's basically it. So that's how you can handle these exceptions in Python. So that's how we can work with exceptions in Python, and that's basically it. So we have the try, the except, and finally. Okay. So if you're coming from other programming languages, we have try, catch, and then finally. It's the same thing. Instead of having catch, we have finally. Like if you're coming from JavaScript or Java, we have catch, but in Python we have except. Okay. So yeah, that's all about exception and exception handling in Python. Again, if you enjoyed this tutorial so far, make sure to like the video, you subscribe to the YouTube channel, and also you share this content with anyone who you think might find it helpful. Thanks for watching, and see you in the next one. Keep safe.